All right, we're going to go ahead and we're going to talk about factoring polynomials completely. So we're going to keep using this idea of factoring to solve polynomials, and we're going to take this last part here is going to sort of put multiple pieces together. So let's see what we're talking about. Here's our standard. Okay, keep going with it. All right, here we go. Whoops, you're not supposed to see that already. Take a look at 2x times y minus 3y. Okay, so what I want to look at here is there a common factor right away that I can pull out of this? Because again, the idea is right now all I'm going to do is factor it. So I'm going to rewrite this by trying to find a common factor between those two monomials, right? 2xy and negative 3y. And I'm going to try to factor out a common factor. Well, hopefully you can see that y is a common factor, okay? I've got y on both of these, okay? So I'm going to go ahead and I'm going to pull y out of there. So I'm going to get y, right, times 2x minus 3. Okay? And again, remember y, I'm looking for a common multiplier, right? The thing that's being multiplied on both of these parts, that would be the factor. Okay? So I'm going to use that idea on a problem like, where is it? There it is, like this one, okay? And again, what I'm going to do here is I'm looking for a common factor of things that's multiplied. Well, what I did here is instead of, notice here we had y, right? Y in both of them. Well, if you notice, the only difference is x plus 4 would be the same as y. Okay, so what I'm going to do here is I'm going to look at this and I'm going to say, okay, this thing, even though it's an addition problem, right? Even though this is a binomial, this binomial is part of this multiplication problem, right? It's 2x multiplied by this whole thing here minus 3 times this thing here. Okay? And so what I'm going to do here is I'm going to say, all right, well, I can pull x plus 4 out of both of them, and I'm left with 2x minus 3. Okay? Again, sometimes factors are going to be something more than just a single number or a single variable. Sometimes it's going to be more of an idea or even, like in this case, a binomial. Okay, and then once you get this, you'll see hopefully that when we set this equal to 0, we can use our zero product property to solve for x. All right, let's move along. All right, x cubed plus 3x squared plus 5x plus 15. Now, I'm looking at this, and you're probably saying, wait a second, Mr. Clark. There are 4 terms here. We've only been dealing with trinomials. Okay, well, this is where we're going to move up from here. So first thing I'm going to do is I'm going to look at, okay, this is a degree of 3. Okay, that's going to imply that we have 3 solutions here. I also have 4 terms. Okay, and I can't combine any of these. Is there a common factor that I can pull out of all of these? No, there isn't. So what we're going to do this thing is we're going to sort of do this idea of called factor by grouping. And what I'm going to do is I'm going to say, okay, let's see, what if I take 2 of these things and 2 of these things and I sort of put them together. So let's group this and 5x plus 15. Okay, so I'm going to group those. All right, and what the idea here is once I group these, is there a common factor in here that I can pull out, and a common factor in here that I can pull out, and then what I'm left with is a similar binomial. All right, so let me just do this, and hopefully it'll start making sense. X cubed, 3x squared. This has a common factor of x squared. So from here, what I'm going to do is I'm going to say, okay, x cubed divided by x squared. I'm going to be x. And then I have 3x squared, right? 3x squared divided by x squared. This is going to be 3. Okay? Then on this side, I'm going to get plus 5x squared plus 15, right? So what here I'm going to do is I'm going to say, ooh, there's a common factor of 5. So I take out 5. Okay, and I'm going to get x plus 3. Okay, now I'm here. And now what you notice is, look, we have common factors of x plus 3. So now I can pull out of x plus 3 a factor of each of those. And I'm left with what's left inside, right? I take this piece and I divide it out. I take this piece and I divide it out. And I'm left with x squared plus 5. Okay, and now I've factored it. Now, let's take a look at this another way. Let's say, again, the idea is to find sort of things that have common factors. So I'm looking for pairs of terms here that have common factors. So let's say you look at this and you go, oh look, 3 and 15. So maybe you want to do 3x squared and 15, and you want to put those together. And then you look at the other one and you say, okay, well that's x cubed and 5x. Okay, well that's good too because this has a common factor of x and this has a common factor of 3. Okay, so let's do that. So let's pull out, let's see, if I take out 3 from here, I'm going to get 3, and I'll get x squared plus 5. Okay, and then I'll do here, and I'm going to pull out just x, and I get x squared plus 5. And I have a common factor now of, again, x squared plus 5. And what am I left with? I'm left with x plus 3. Now, technically it's 3 plus x, but we're going to write the variable first, so x plus 3. And if you notice, that's the exact same thing. We have the same answer there. Okay? And so play around with it. See if there's another pair that you can put together. I don't think, well, maybe. You can try. See if there's another pair of terms you can put together. And in fact, let's just try that. Let's go ahead, and the only thing we didn't combine, we did x cubed, let's do 3x squared and 5x, right? That has a common factor of x that I can pull out. And then let's try, oops, that's not a multiplication problem, it's an addition problem. And then we'll do x cubed plus 15. Okay, and so then I can pull out an x from here, right? And I'm left with 3x plus 5. But once I get here, there's no common factor. Right, so I'm going to get nothing to pull out of there, which doesn't give me a common factor between the two pairs here. So that one doesn't work. So I wouldn't do that, and I would start over and say, okay, well, let me group some different ones together. All right. So just because you put two together doesn't mean it's going to work factoring. So then maybe try another one. Try pairing putting two pairs together differently. All right, let's move on. Let's try another one. Okay, why don't you try and go ahead and do this one? Okay, hopefully in the process of doing this, maybe you tried putting x cubed and 6 together, these two together, but what you notice there is there's no common factor here, right? There's no common factor between x cubed and 6. So let's look at something else. What about we can do x cubed and negative 3x squared? We could do that one, x cubed and negative 3x squared. Put those together, and then I can have a positive 2x and a negative 6. And so we pull this out to x squared from here, and I get x minus 3 plus, and I'm going to get 2 out of here, and I get x minus 3. Ooh, nice. X minus 3 comes out of both. And then I'm left with x squared plus 2. There we go. Factored. Now, again, let's say you did it a different way. And let's say you did x cubed plus 2x, and then you did negative 3x squared minus 6. All right, so I'm going to take these two, oops, I'll put these together like this, and I should really say plus a negative like this. Okay, and then I'm going to pull out x from here, and I get x squared plus 2. And what I'm going to do here is notice, okay, negative 3, negative 6. I'm going to take out negative 3, okay, and I'm left with x squared plus 2. Aha, looks good to me. X squared plus 2 and x minus 3, same deal. Okay, moving along. Let's try this one. Ooh, now what? We only have 3 terms here. What are we going to do? Well, let's go ahead and let's try factoring out again. This is sort of like the 39 the other day where you had that. Remember that problem said y to the 4th minus 2y cubed plus y squared? This is sort of the same idea here. So let's look. Anything we can factor here? Let's pull out the biggest common factors. So I can take out, let's take out, let's see, what do we have in common? 4, 4, and 4, I believe. So we'll do 4, and there's an x in all of this. So take 4x out. What am I left with? We have x squared minus 11x. Let's see, 96 divided by 4 is going to be 20, what is that? 96 divided by 24. So plus 24. Okay, looks good. Now wait a second. Let's see. Hold on a second. This is a trinomial. Can I factor this one? Well, let's see. This means I'm doing a sum of the products. This means the middle terms are going to be, or the terms are going to be x minus something and x minus something. And I'm looking for two factors of 24 that add to 11. Well, let's see, 24 and 1, no. 12 and 2, no. 6 and 4, that's 10. 8 and 3. 8 and 3. And now I have a nice, very nicely factored, right? And this is the idea of factoring it completely. I've taken it, I factored out a 4x. I can't just leave it here because I can continue. I can factor this more. You always want to keep looking and say, can I factor that some more? Can I pull something else? Is there another factor, another common factor that I can do? So why don't you go ahead and try that one. Go. Okay, hopefully you looked at this and you said, well, there's at least h squared that I could take for both of these, right? And 2. Okay, so what am I left with? Well, this 25h squared minus, what is that going to be, 1? Okay, well, this is almost there, but this right here can be, this can be factored also because I have a perfect square and a perfect square and a difference. So I'm going to get 2h squared, and this will be 5h minus 1 and 5h plus 1. And I think I'm done. I don't see any more factoring that I can do here. All right, let's try solving. What happens when we solve here? Okay, we'll do this will be the last one, and then we'll do some practice in class. All right, so first thing I'm going to solve. I know this is a degree of 3. Okay, so 3. So I should have 3 solutions here when it's all said and done. So let's go ahead and factor this thing. I'm going to look at this first thing I can do. Are there any common factors that I can take out of all of this? Well, yes, there's an x. So I'm going to get x squared minus 7x plus 12 is equal to 0. Okay. Then I'm looking for, let's see, can I factor this thing? Well, yes, I can, right? It's going to look like, let's see, I'm looking for the sum of the products, right here, the sum of the products that add to 7. Well, 4 and 3 add to 7, so I'm going to get x minus 4 and x minus 3, right? I know that they're both negative because this tells me they're negatives, and this is going to be equal to 0. Now, I can say 0 product property if at any point any of these terms, right, any of these parts are 0, then the whole thing will equal 0. Well, how does that happen? That happens when x is equal to 0. It happens when x minus 4 is equal to 0, so that means when x is equal to 4. It also happens when x is minus 3 is equal to 0, so when x is equal to 3. So I have 1 solution, 2 solutions, 3 solutions. And there we have it. Okay. Now this one's a little more complicated. We're gonna definitely practice this a little bit more because you need to just do a lot of practice just to see a bunch of problems where you can just even know where to start. And what you'll find, I think, a lot of times is you get to the point where you factor it most of the way, but there's sometimes one extra thing you can do. So, but we will practice in class. Okay. See you soon.